Hello students, welcome to this video tutorial on calculating theoretical probability method 3 using tree diagrams part 3. Alright, let's go on to example 3 and you'll notice none of the tree is given to you. So make sure you've got a short ruler out so that you can draw this tree neatly. Okay, so let's start with the beginning. In the school garden, you can plant tulips, roses, or daisies in pink, white, or yellow. Draw a tree diagram to find the number of possible outcomes. Okay, so the first thing you have to identify is the two events. So what's the first event here? What would you call this? Tulips, roses, and daisies. Even if you've never seen one, hopefully you know that these are flower types. Okay, so these are flowers. And then, what's the next event? Well, we have in either pink, white, or yellow. So how could we summarize this event? Well, this is going to be color. Okay, so that's the first thing I want you to fill in here is flowers and then color. So for event 1, I'm going to type in flower. And for event 2, I'm going to type in color. Okay, so it's very important that you understand the two events. Okay, so let's concentrate on the first event here. So we have a choice of flower, tulips, roses, or daisies. So on our first branch here, how many stems or trunks or branches will we have? Well, in example 1 and 2, we always had 2 branches. But in this case, event 1 has 3 possibilities. So you're going to have to draw 3 stems coming for event 1. Then, for event 2, for each end of the branch, you'll have to make another branch that has 3 branches. So does that make sense? We've seen 3 branches before in example 1. So this is what the event 2 is going to look like, except for this one, event 1, we're going to have another branch coming out the middle. So what I'd like you to do is I'd like you to try and draw that in pencil. Just draw it in very softly, and then I want you to see if you can kind of map out what the tree is going to look like. So I want you to press pause here, and I'm going to give you a couple minutes to do that, okay? So don't press too hard in case you have to erase things. All right, I want you to press pause right here. Okay, I'm back. So hopefully your tree diagram looks something like this. Okay, so it's always hard to space out a tree. When you're given nothing and you have to draw the tree diagram yourself, it is very challenging. It takes some practice. Okay, so if you need to kind of fix yours up so that it's going to be well spaced, then you need to press pause here. Okay? Okay, so I'm going to continue and start filling in the words on the end of each branch. Okay, so let's look at event 1. Event 1, remember, was flowers. So there are 3 types of flowers. So I'm going to start with tulips because that was the first one that was given in our question. The second choice of flower was roses. And then the third choice of flower was daisies. Okay, maybe that's this line down here. Daisies. Okay. All right, so that's event 1. Okay, so from each of these branches, then we have another 3 branches. And what do these 3 branches represent? Well, they represent event 2, which is color. So have you figured out what's going to be written at the end of these branches? Well, we have 3 choices of color. And in the question, they came in this order: pink, white, or yellow. So I want you to fill those in. Okay? And once you get this set of 3, they're going to repeat on the other 2 sets of 3 branches. Okay, so we're going to have a repeat of pink, white, and yellow. And that's also going to repeat down here in the lowest set of branches. We have pink, white, and yellow. So like I said a couple minutes ago, it's really hard to kind of map out what the tree diagram is going to look like, but it's a lot easier to draw it with a pencil and a ruler than I had to draw it using the computer. This took a really, really long time. Okay, so have you figured out how to do the outcomes? So what you should do is, I want you to press pause and I want you to list all the outcomes. And then when you've got them all listed, I'll have them all up on the screen. So I'm going to do that as well. So I want you to press pause here. Okay, I'm back. So hopefully you were able to come up with the same outcomes. So we have tulips pink, tulips white, tulips yellow. Then we have roses pink, roses white, roses yellow. And then we have daisies pink, daisies white, daisies yellow. You got to make sure that you got to be very careful about the order of things. Okay, so do you remember the next step? The next step is writing the fractions for each of the branches. Okay, so let's look at event 1. When we choose a flower, we have 3 possible outcomes, right? So what is the probability of choosing tulips? It's going to be 1/3. The probability of choosing roses, 1/3. And the probability of choosing daisies, 1/3. Okay. So let's go to event 2. How many options or outcomes do we have? We have 3 possible outcomes. We have pink, white, or yellow. So each of these branches is going to have the same fraction, 1/3. There is a 1/3 probability you're going to choose each of these colors. So once you've filled those branches in, make sure, don't forget, to continue to write the fractions for all of the branches. All of the branches have to have a fraction on them. Okay, these fractions represent the probability of that event occurring. Now I'm going to go to the last set of branches at the bottom and fill them in 1/3, 1/3, 1/3. Okay. So we're ready to start the probability calculations. So if we follow the branches for tulips pink, tulips, the first fraction is 1/3. And then if we follow the pink stem or the pink branch, we also get 1/3. So we get a multiplication statement of 1/3, times 1/3. Multiply the numerators, 1 times 1 is 1. Multiply the denominators, 3 times 3 is 9. Okay, so I'm going to press pause here, you're going to press pause, and you're going to continue all of the probability calculations. Okay, press pause here. Okay, so I'm back. Did you notice that there wasn't as much room to write those fraction calculations as in the other 2 examples? All right, so hopefully you got a probability of 1/9 for all of these outcomes. Okay, so they are equally likely to occur. You're as equally likely to choose roses and yellow as you would be to choose tulips and pink. So one more thing to check. If we were to add 1/9 plus 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 1/9, we would get 9/9 or 1. Okay. Let's go on to the last example where I'm going to get you to be even more independent. Okay. You flip a coin. Example 4. You flip a coin and spin a 4-section spinner that has 3 sections painted blue and 1 section painted red. So the first thing you need to understand is, what does this spinner look like? So best way to visualize it is to draw a little diagram. We know it's a 4-section spinner. It says so right here. 3 of the sections are painted blue, so I'll just put a B, B, and B, and then 1 section is painted red, R for red. So now you know what the spinner looks like. Flipping a coin, well, you know what flipping a coin does. We have heads or tails. So what is the first event going to be? Well, the first event is the coin flip. And then what is the second event going to be? The second event is going to be the spinner. Okay? All right. So I want you to kind of figure out, what is this tree going to look like? The first event, coin, we have 2 options, 2 outcomes. And then the second event, the spinner, we have 4 outcomes. So I want you to press pause here. Make sure you've got your short ruler and pencil, and I want you to map out what this tree diagram is going to look like. Okay, press pause here. Okay, I'm back. So does your tree diagram look like this? We have 2 branches to start off with, because we have only 2 options for the coin, 2 outcomes. And then we have 4 branches for event 2 for the spinner, because it is a 4-section spinner. Okay, so if you need to press pause here so that you can adjust your tree diagram, do so, and then come back when you're ready. Okay, so let's fill in some information here. So when we flip a coin, what are the 2 outcomes? Well, we can get heads, or we can get tails. So that takes care of event 1, the coin flip. We have 2 options, heads or tails, 2 possible outcomes. Now when we go to event 2, the spinner, remember what the spinner looked like? It had 3 sections of blue and 1 section of red. So what is the first possible outcome? Well, the first possible outcome is we land on blue. What's the second possible outcome? Well, the second possible outcome is also we can land on blue. The third possible outcome, we can land on blue. But the fourth possible outcome is we can land on red. Remember, there's that 1 section that's painted red. So now that you've figured out this part of the branch, then you just copy it for the lower half. So those options, those outcomes, sorry, were blue, 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 and red. Okay, so now that we have all of our information, I want you to list all of the possible outcomes. So I want you to press pause and then come back when you've listed all the outcomes. So press pause now. Okay, I'm back with all of my outcomes. So let's check your tree with mine. I got heads blue, heads blue, heads blue, and then heads red. Be careful about this one. Okay, remember there's that 1 combination that has red in it. Then in the lower half of the tree, I've got tails blue, tails blue, tails blue, and then tails red. Okay, so hopefully you got those correct outcomes listed. So now the next step is I want you to write in the fractions. So I want you to press pause. I want you to write in the fractions for all parts of the tree and then come back to the video. Okay, so press pause now. Okay, I'm back. So did you get these fractions on your tree diagram? Okay, so hopefully by now you know what you're doing. So I want you to fill in all of the probability fraction calculations. So I want you to press pause at this time and then come back to the video when you've got all the probability calculations done. Okay, press pause now. Okay, so I'm back. So check your calculations with mine. Did you get a probability of 1/8 for all of these outcomes? Hopefully you did. So you might be thinking at this point, are all the probability trees going to look fairly similar, or are they exactly the same? Well, most of them are very similar. However, I can get very creative in the type of questions that I can ask you. So you'll notice that this example has actually got a couple questions at the bottom. So let's look at question 1. What is the probability of getting a combination that has blue? Okay, so let's go and have a look at all of the combinations that have blue. So what I'm going to do is I'm going to underline all of those combinations. So that is this probability, this probability, this probability, this one, and this one. So I want you to show your work here. We have 1/8 plus 1/8 plus 1/8. So that takes care of this one, and this one. And let's keep it going. Plus 1/8. That takes care of this one. And 1/8. That's this one. And 1/8. Now the good thing is all the denominators are the same, and that's what we like in an addition question. So the denominator stays the same. Something over 8. We have 1 plus 1 plus 1 plus 1 plus 1 plus 1 equals 6 over 8. Now, don't relax yet. You're not finished. You should always be looking at these fractions and asking yourself what question? Yes. Is it in its lowest terms? Well, 6 and 8 are both even numbers, so it's not in its lowest term. So if we divide the top and the numerator and the denominator by 2, 6 divided by 2 is 3. 8 divided by 2 is 4. So the probability of getting a combination that has blue is 3/4. All right, let's go to question 2. What is the total probability of getting, now total is a good hint that we have to use addition. What is the total probability of getting a combination that has red? Okay, so let me underline the combinations that have red, and then let me circle those probabilities here. So this is going to be much easier. So we have 1/8, which takes care of this probability, plus 1/8, which takes care of this probability. So denominators are the same, so the denominator will stay the same. 1/8 plus 1/8 equals 2/8. Now don't walk away yet. 2/8 is not in its lowest form. They are both even numbers, so we know that they are both divisible by 2. So if we divide the top by 2, 2 divided by 2 is 1. If we divide the bottom by 2, 4 divided by 2 is 4. So what is the total probability of getting a combination that has red? It is 1/4. Okay, so I'm going to ask you a lot of interesting questions like this that allow you to use the data from your probability tree. Okay, thanks for watching this series of 3 very strenuous videos. Thanks again. Bye.